So managerial economics, by definition, is the integration of economic theory and decision sciences to integrating managerial problems optimally. So managerial economics basically looks at applying economic theory and decision sciences to solving managerial problems optimally. So I'm going to combine two key things here. There's what we call economic theory, and which comprises of micro and macroeconomics, and we're going to look at decision sciences, which comprise of mathematical economics and decision making. So the key for you to understand basically firstly is calculus. So calculus, we're only going to look at the power rule for starters. Then I'll take you to a few questions that require calculus. So we're going to look at what dy dx is. So if we're going to have a function given by y is equal to axn, so dy over dx is equal to n a x n minus 1. So this equation, so what does this equation talk about? So this equation simply means if you have y is equal to 5x to the power 4, dy over dx is equal to, you multiply the numbers, 5 times 4, then you subtract 4 minus 1 there. So this is going to be 20x to the power 3. I want to be as basic before I start looking at the marathon. So dy, because y is on this side, dx, because x is on the other side. So just multiply 5 times 4, which is 20, and subtract 1 from the power, we get 3. All right. So in the context where we have a long equation, which is given by 4x3 minus 2x2 plus 5x minus 10. So this is called dy over dx. So this will be 12. Who wants to try? We're going to have 12 here. X to the power what? 2 minus what? 2 times 2 is 4. So 4x to the power 1. We never write the 1. Then plus, there's an invisible 1 there. 1 times 5 is 5. 1 minus 1 is 0. So 5. If you have a constant, it drops out. So this is what we call the derivative. So when differentiating, for instance, we have TR is equal to 170 minus 5q squared. So this will be the what? The TR over the Q. Because this side there's TR and this side there's Q. So we call it the TR over the Q. TR stands for the total revenue. When you differentiate it, the name changes to marginal revenue. So help me differentiate this. 170Q becomes what? 170. 5Q squared becomes what? 10Q. Are we together? So we have total revenue, we have total cost, we have total profit. So when we differentiate these ones, the total revenue becomes what? Marginal revenue. When we differentiate total cost, we call it marginal cost. When we differentiate total profit, we call it what? Marginal profit. And when we equate these to 0, we are optimizing. So marginal revenue, when we get it to 0, what are we doing? Finding the maximum revenue. Marginal cost, when we equate it to 0, we're finding the minimum cost. Marginal profit, when we get to 0, we're finding the maximum what? Profit. These are key important principles that you need to know. So we have about 3 subsidiary formulas that you need to know under revenue analysis, under cost analysis, and under profit analysis. So total revenue, we need to know that it's given by price times quantity. Average revenue is given by, if we divide the total revenue by quantity. Marginal revenue is given when we differentiate the total revenue with respect to quantity. Do we understand? So total cost is equal to what? Total fixed cost plus total variable cost. So anything divided by a quantity is called average. So total cost, when divided by quantity, we call it our average total cost or average cost. Total revenue, when you divide it by quantity, it's average revenue. Total fixed cost, when divided by quantity, we call it average fixed cost. Total variable cost, when divided by quantity, we call it average variable cost. In short, the T becomes an A. Are we together? So lastly, when we differentiate the total cost with respect to quantity, we're going to call this our marginal cost. Let's go to profit analysis. Profit is simply when you subtract total revenue minus total cost. Always remember to put the total cost in brackets. So when the profit is equal to 0, we call that the break-even point. Or the break-even point is simply when the total revenue is equal to the total cost. To break even is simply to be at par, where you're neither making a profit or a loss. So when your total revenue is equal to our total cost, what we get is called the break-even point. Then when you differentiate the profit, we call that the marginal profit. So the marginal profit is when you differentiate the profit, and when we equate the marginal profit to 0, what we are actually finding is the maximum profit. Now, with that being said, I need you to understand the following minor examples before I take you to the exam. So in an instance where you're given our price as 170 minus 5Q, and our total cost is given by
a bit fast.
All right.
So I think before you even did the break-even issues, there was where you ended with D something, because I was writing.
Okay, let's do it.
Yeah.
Let's do a quick, can you remember? Or maybe I start giving you examples. It'll help you remember. All right. So let's go to revenue analysis. How did I say? How do we find the total revenue? Plus, what's the formula for total revenue?
Price times
times.
Excellent. Price times quantity. How do we find the average revenue?
Total revenue divided by quantity.
I hope that's coming from your head. Correct. How do we find the marginal revenue?
The TR divided by DQ.
The TR divided by the Q. So if our TR was 170 Q minus 5Q squared, how do we differentiate this one? The TR over the Q. What do we get? 170Q becomes what?
170.
170, correct. 5q squared becomes what?
10q.
10q. We're not memorizing the answers because this calculus part is very important. Look, I just want the derivatives of these figures here. All right, just give me the derivatives of these figures here. So 10q becomes what? Just the derivative.
10.
10.
10q2.
20. 20q.
20q. 10q3.
30q2.
30q.
Squared.
Good. 10
Squared.
what?
0.
0.
It's a constant. 2q4.
8q to the power 7.
8q3.
To the power 3, yeah.
About 3q1/3. Q negative 2/3. All right. So far, I'm happy with all of you. This is very important.
Thank you.
So this is what we call the power rule. But when you're doing what we call implicit differentiation, we differentiate as follows. Whatever you're doing, you just differentiate implicitly. So for instance, du over dx, this is called the maximum utility of x. So you're interested in the x, you leave the y as it is as a dummy, y7. Let me just use a different color. So you cut and paste y as it is. So y7, leave it as it is. So we're going to remain with what? 5x3. Differentiate 5x3 from me.
It's 15 to the power, 15x to the power 2.
15x2, correct. Right. Then if we're going to differentiate du over dy, what we're interested in is in the marginal utility of y. So which one is our dummy? x3. Just cut x3. What remains? 5y7. So differentiate 5y7. What does it become? 35y what?
Y6.
Good girl. So with this, it covers about 35% of the work in this course because this is very important and it gives you the blueprint of whatever remains, just application. Just for the sake of a few who are a little bit behind, suppose we had u is equal to what? 10L 0.5, K 0.5. So dq over dl, this is called the marginal product of labor. Our dummy is what? K is 0.5, right? Then we're going to differentiate 10L.5. What is 10L.5? It will be 5L negative 0.5. Then if we're going to differentiate dq over dk, K stands for capital. This is going to be the marginal product of capital. Our dummy will be what? L 0.5. And we're going to remain with what? 10K 0.5. When differentiate that one, we're going to have 5K negative 0.5. Now you must understand that we usually love to arrange things in alphabetical order. So if you're given utility of 2xy half, so this will be what? U x half, y half. So du over the x is called the marginal utility of x. Which one is our dummy? Y half, right? What are we differentiating? 2x half. 2x half becomes what when you differentiate? 2 times half becomes what? 1. We never write 1. And subtract 1 from the half, we get negative half. Then we go to du over dy. This is called the marginal utility of y. So here we're going to have our dummy. We're interested in the y, our x half is our dummy. So we're going to remain with 2y half. 2y half when differentiated becomes what? 1y negative half. All right. So I'll take you briefly to grade 12. But before I take you to grade 12, let's now apply whatever we've been discussing under revenue analysis and under cost analysis. So with these two functions here, I need you to help me calculate the marginal revenue and average revenue. So let's start with total revenue. Who remembers the formula for total revenue? Formula for total revenue?
P times quantity, price times quantity.
In this case, we already have the price, which is 170 minus 5Q. Quantity we're never given, we impute it. So we put the Q there. So meaning our total revenue is 170 Q minus 5Q squared. Just expanding it. Are we clear? All right, who can remind us, how do we find the marginal revenue?
It's going to be equal to the TR over the TQ.
So in this case, we're differentiating this TR. So what do we have?
170
170
minus 10Q.
minus 10Q, correct. So how do we maximize revenue? Who remembers to maximize revenue? What happens? MR is equal to what?
MR is equal to TR.
0, correct. So if we're going to solve for Q, what happens? What is our Q? We divide both sides by 10. So our Q becomes what?
710.
So to maximize is to find both price and quantity. That will give you the highest what? Revenue. So this would be what? 170 minus 5Q. So we're going to have 170 minus 85. So meaning the price that to maximize revenue is 85. So we have optimized. So this is what we call optimization. Okay, then how do we find the average revenue? Who remembers? Average revenue is what? Total revenue over what? Quantity. Our total revenue was 150Q, 170 minus 50Q squared. So here advise that you single out the Q throughout. So this will give us 170 minus what? 5Q. So not 50, that's 5. So usually for a perfectly competitive market, the average revenue is same as the price function. All right, so we're also given the total cost as 40 plus 50Q plus 5Q squared. So you need to understand that total cost is a combination of two things. Total cost has the fixed aspect and the variable cost. The fixed aspect is the constant part of it. So in here, what is the total fixed cost? The 40. The one which has no letter. Okay, meaning average fixed cost is simply, remember the formula, total fixed costs divided by what? Quantity. So in this case, when you divide 40 over quantity, that's called our average fixed cost. Conversely, our total variable cost is simply the part which has letters throughout. We just identify it. This is what? 50Q plus 5Q squared. But to make it average, we just change this T to an A by dividing the total variable cost over quantity. So here we're going to have what? 50Q plus 5Q squared divided by Q throughout. So what do we get here? Final answer becomes what? 50 plus 5Q. And marginal cost, somebody, how to find the marginal cost? When you differentiate the what? Total cost over the quantity. So the total cost function, let's differentiate it. 40Q plus 50Q, 40 plus 50Q plus 5Q squared, what do we have? The 40 drops out because the constant at 0. Then we're going to have what? 50 plus 10Q. Any questions so far?
Which one are you differentiating?
This, the total cost.
Oh, okay. All right.
The 40 is 0, the 50Q is 50, the 10Q squared is 5. Right. Then we go to the profit. Who remembers the formula for the profit?
Profit is equals to total revenue minus total cost.
Excellent. So our total revenue is 170Q minus 5Q squared. And our total cost we're given as what? 40 plus 50Q minus 5Q squared. So I advise that you put the total cost in brackets so that the negative operations will play. So the negative here will negate everything in the that is positive. And if there's anything positive, they will become what? Negative. Anything negative, they become positive. So we put the like terms together. 170Q, we liken it to the 50Q. Minus 5Q squared, we liken it to minus 5Q squared. Then minus 40. So the profit function, therefore, will become 170Q minus 50, we get 120Q. Minus 5, Q squared will be minus 10Q squared. Then the 40 will remain there. So this becomes a profit function. So to maximize profit, we first differentiate it. The pi stands for profit over the Q. This is called the marginal profit. So 120Q, we get 120. 10Q squared, we get 20Q. What happens to the 40? It drops because it is a what? Constant. So, to maximize profit, who remembers the rule? Our margin of profit must be equal to 0. So, we had our price is equal to 170 minus 5Q. We had our margin of profit, which is equal to 120 minus what? 20Q. So when you get this to 0, we are maximizing profit. So 120 is equal to 20Q. We divide both sides by 20. So meaning our Q is equal to 6. But we're not done yet. To maximize according to managerial economics, we find the price and quantity that will give us the highest profit function. So where there's Q, we're going to put 6. So profit has been calculated already, but this is a price function. So when we're going to calculate 170 minus 30, we're going to get 140. So this is how we maximize our profit function. This is how we maximize our profit function. Are we together?
You can go through for the last time.
All right. So at what point were you lost? The profit is equal to the total cost. So our total revenue minus total cost is our profit. So we had calculated our total revenue here by multiplying price and quantity. So this gave us 170Q minus 5Q squared. And the total cost was already given. We get it as it is. So in this case, we have total revenue 170Q minus 5Q minus, in brackets, 40 minus 50Q plus 5Q squared. So this minus will make everything negative, minus 40 minus 50 minus 5Q squared. If there was a negative there, it becomes positive according to the rules of maths. So this is what we call expansion. And now you rearrange them according to the like terms. 170Q will go with a minus 50Q. Please, nothing is crossing the equal sign, so get it as a sign with the sign as it is. So 170 minus 50 is 120. Then minus 5 minus 5, it will give us minus 10, which is that one. Then the 40 is alone. So this is what we call the profit function. Is that clear so far?
Yes.
Then when you differentiate the profit function, 120Q is 120. 10Q squared is 20 minus 40. So this is called the marginal profit. Okay. So once that is done, we now equate to 0. That is called maximizing. So 120 minus 20Q. So we equate this to 0. So 120 minus 20 is equal to 0. So when this 20 comes inside, it will be a positive. Divide both sides by 20, our Q is 6. So this 6 is what you put in here. So when we find our Q, we put it in here. So we're going to have our P, which is 170 minus 5 times 6, which is 120, 140. Right. So roughly, I'm trying to sketch and preempt questions the way they come in the exam setup. I've covered a wide scope. Now I want to take you through some of the exam type questions. Okay, so I want now to reflect on exam type questions so that we can speak the same language. Because if I went to the exam exactly, you would be asking a lot of questions. So let's get to business. So we're going to look at question number So all these questions, you should reach a point where you understand them after I take you through the basics. So let's look at question number 6. A story publishing company has its total output in terms of books and total cost, assuming the total cost function is given by that. Let's find the total variable cost, average variable cost, and marginal cost. This is from your lecture. Okay, so who remembers? Let me put this on my clipboard. Who wants to try? To find the total variable cost. What is the total variable cost? So what is our total cost function placed in this case? Our total cost function is given by what? 120 plus 50q minus 10q squared plus q to the power 3. So which one is a fixed cost and which one is a variable cost from this equation?
The fixed is the 120, then these which have coefficients, they are variable.
Excellent. So our total fixed cost is the one which is a constant, the number 120. Our total variable cost are the ones with what? Letters. Right? So we have found our total variable cost. So how do we find our average variable cost? What's the formula for average variable cost?
Divide by the Q, the whole equation.
Good. The total variable cost by the Q. It is called average. If we divided the total variable cost by Q, it would be called average fixed cost. So I advise that you individualize the division to avoid what? Making errors. All right. So here we divide by Q, by Q, by Q. So what becomes our average variable cost? 50 minus what? 10Q minus what? Q3. Not Q3, but Q2. So that becomes our average variable cost. Okay. Are we together? Anyone lost behind? Anyone lost so far?
So total variable cost just ends on 50q minus 10q squared plus 3. Plus q3.
Yes, it's just this part here as it is, just
Just that part. Okay.
that part, yeah. Then fixed cost is this part. All right.
Oh.
Just a quick recap. So what we are saying is this. Okay. To calculate our total variable cost, total variable cost is simply the inputs such as labor and inputs that are required to produce a specific output. So it's calculated by the fixed costs in form of the total cost. So when you subtract the so total variable cost is simply the other part that has letters in another way. So average variable cost is simply total variable cost over quantity. So we had our total cost here. We divide by our total variable cost, we divide by quantity. So in this case, we just divided this variable part by quantity. So 50 Q and Q remains 50. 10Q squared remain 10Q. Q3 over Q would be Q2. Okay. So marginal cost, who wants to try the marginal cost? How do we find the marginal cost?
Marginal cost should be the derivative of the whole equation, the total cost equation.
Okay. So it's a derivative of the whole equation. That's right. So let's just differentiate the whole equation. So let's differentiate the whole equation. So marginal cost in this case will be what?
50.
The TC over the Q. So we're different. The 120 falls out. So 50Q becomes what? 50.
50.
Then 10Q squared becomes what?
20Q.
Then Q3 becomes what?
2Q squared.
3Q2, isn't it?
Yes.
Right. Are we all together so far? Is anyone behind? Please ask now or forever hold your peace. Any questions so far? All right. So if that is clear, we can now proceed to the next part of the question. And the next part of the question is asking us to calculate the level of output at which AVC and MC are minimum. So also to prove that AVC and MC are U-shaped. So to find the minimum, because we always minimize costs, so we differentiate and equate to 0. So we're finding Q when we differentiate. So what was our AVC? Quick, can you remember? What is our total variable cost? Those that haven't spoken.
50 minus 10Q minus Q squared.
50Q minus 10Q squared. Plus what?
No. Plus
Minus
Q.
10Q.
So this is our total variable cost. So what becomes our average variable cost? We divide by Q. This would what? 50
50 minus 10Q plus Q squared.
Q squared, correct. So how do we minimize this one? By differentiating the AVC over the Q.
Excuse me. I think the equation there should be 50 minus 10Q. Which one are we differentiating? Maybe I'm behind a bit.
Firstly,
AVC.
I asked what is our total variable cost? Simply this part here. All right.
Oh,
Then give me the average variable cost. We divide by 50 in each of these ones. So this is 50, 10Q, Q2. So we now
okay.
need to differentiate the AVC. So what do we do to AVC?
Okay.
Differentiate it. So this becomes what? Minus 10 plus 2Q. Then whenever we are minimizing, we get to 0. So this guy will go the other side. So 2Q is equal to what? 10. So what is our quantity that minimizes average variable cost? It will be 5. All right, together?
No, I'm a bit
So
behind here.
whenever you're asked to minimize or maximize, there are 3 steps that you need to do. Number 1, find that function. Number 2, differentiate that function. Number 3, equate to 0. Number 4, solve for what? For Q. Find Q. So this question is asking us to minimize which function? The average variable cost. So are we clear now? We found the average variable cost here. 50 minus 10Q plus Q squared. Are we together?
Yes.
So this is step 1. 50 minus what? 10Q minus what? That's Q squared. Step 2, differentiate. So 50 becomes 0. 10Q becomes what? Minus 10. 2Q squared becomes what? 2Q. Step 3 equal to 0. When this one comes inside, it'll be 10 is equal to what? Q. So divide both sides by what? By 2. So meaning what is our Q? 5. So this is the output that minimizes average variable cost. Is this clear? Are we all together? Pardon?
What I saying?
Are we together?
Yes.
Okay, so let's go to the next question. It's asking us to do what? To minimize our marginal cost. So firstly, before we minimize our marginal cost, somebody help us find the marginal cost for this function. What is our marginal cost? MC is equal to what?
The derivative of the
DTC over DQ. So what is our
DQ.
DTC?
Q.
50
Divided by
minus what? 20
midway.
plus what? 3Q2. Are we agreeable? Are we agreeable?
yes.
So let's go to the steps that we're doing. Step 1, find the function. What function are we minimizing? The marginal cost. So what is our marginal cost? Our marginal cost, according to our data here, is 50 minus 20Q plus 3Q2. 50 plus 20Q plus what? Plus 3Q2. So the next step, what do? We differentiate. So on differentiate, the MC over the Q, what do we have? Minus 20 plus 6Q. Then we equate to 0. Minus 20 plus 6Q. Then we solve for Q. 20 is equal to what? 6Q. Then we divide both sides by 6. What do we get? Q is equal to what? 3.3. Are we together? Okay. All right. Okay, so are we together so far? So are we together so far? Any questions? Any questions so far?
result. Just right.
Please ask at this point before I proceed. Anyone behind with finding the minimum points that will maximize those key points? Okay. So now we want to learn how the sketch will come out. So we've been asked to, in the question, we've been asked to find AVC to prove that it is U-shaped. So if you're going to draw and put the points, you can use any scale. Scale 1, using those functions, you discover that it will come out something like this. Our average so this one was lowest at 3.33. The other one was lowest at what?
5.
5. Right. So our marginal cost and average variable cost. This is how it will come out. So you can use any scale. Okay. I sent all these solutions already on the group. Please find time to go through. These questions are usually repeated time and again. All right. So we've also been asked to find AVC and MC for the level at which our AVC is minimum. Find AVC and MC for which our AVC is minimum. So AVC was minimum at what? 5. Then just substitute this quantity of 5 into the values of the AVC and the MC. They're just asking you to find the value of the average variable cost and the value of the marginal cost at the point when AVC is minimum. So we already calculated the point at which AVC is minimum, and that was what? That was 5. So we put 5 in the two functions. Then you're going to get your full marks in that. All right. So I'll share the recording that you can go through. This is very important. Okay. Lastly, we'll look at this question here. Question number 2. We're given total revenue, we're given the total cost. We're finding the base level of output and the actual profit that maximizes profit. So to take you to our grade 12, like I promised you, if you're given a quadratic equation, for instance, in the form of x, ax squared plus bx plus c, you're going to use a quadratic equation, which simply states that bx is equal to what? Negative b plus minus b squared minus 4ac divided by 2a. So if you're given an equation like 2x squared minus 4 plus 2x, which one is our a, which one is our b, and which one is our c? So our a, according to the format we're using there, is what? The coefficient of x squared, which is 2. Our b, so 2. And our c, negative 4. So we substitute in this equation to find the value of x. So here we're going to -2 plus minus 2 squared minus 4ac. Our a is 2, our b is -4, and our c is what? And our a is 2. Are you following what I'm doing in here? Identifying our a, b, and c. Before I go into this, is anyone lost on finding the quadratic equation? I repeat, if you're given quadratic equation like this, you need to identify your a, b, and c using the equation ax plus bx plus c. Can we arrange this? Minus 7x squared minus 2x plus 4 equal to 0. So our a in this case will be -7. Our b in this case will be -2. And our c in this case will be +4. So the rest is simply you substitute in what? A quadratic equation. Find your answer. So you need to master this quadratic equation because you will need it to substitute whenever you have a power to the power x. This is already a binomial function. So I adjure you, whenever you're seeing an equation that has a power 3, just know to take you through a quadratic equation. So to start with, for us to find the best level of profit, we need to find the profit function. So who remembers the formula for the profit? Profit is given by what?
Total revenue minus total cost.
Excellent. Total revenue minus total cost. And what are we given here? What is our total revenue? And I emphasize that you put the total cost in brackets, right? So here we're going to have what? Profit is got what? 4q minus brackets 0.04 q to the power 3 minus 0.9 q to the power 2 plus 10q plus 5. Right together? Then what happens with this negative?
Yes.
To negate everything that is negative. Everything that is positive, it will negate them. Everything that is negative will be positive. So what happens to the negative 0.9? It will be positive 0.9, right?
Yes,
Then the
be
10,
negative. To be negative.
then the 5 will be what? Negative.
Negative.
Put the like terms together. 4q will go with which one? 4q will go with which one?
10q.
10q, correct. So 4q, 10q, you're going to get negative what?
14.
-6, right?
Why?
So
Because
4q minus 10q, then minus
The bigger number, if it's negative, you subtract.
yes. 4q to the power 3. Then we're going to have what? Plus 0.9 q squared
red.
5. So what becomes 4q minus 10q becomes what?
-6.
-6. Then
Q.
here what? Minus 0.04 q to the power 3. And here plus 0.9 q squared.
What? Excuse me, sir.
Uh-huh.
I thought it was going to be 14 because the 10 after opening the brackets has become a negative.
Yes, so 4
So,
4 minus 10.
okay. Or the 10 becomes a negative. Oh, okay.
Yeah.
Okay. All right.
Cleared.
Yeah.
Then minus 5. So here this becomes our equation. All right. So when we differentiate this one, what does it become? Negative 6q becomes what? Negative 6, right?
Negative 6.
This
Then
is what?
there it becomes minus 0.12 q to the power 2.
Minus 0.12
12
to the power
q 2.
here.
0.18.
Plus
1.8
1.8 what?
1 q.
Q. All right. All together. So when you take them this side, so we want to equate the derivative to 0. Okay, so if this is 0, we take this everything to the other side. We're going to have what? 0.12 q squared. Minus 1.8 q. Then plus what?
6.
Plus 6 is equal to 0. So if we divide throughout by 0.12, 0.12, 0.12, we're going to have q squared minus 15 minus 50 is equal to 0. So now this is where I'll give you homework. Ask your sons who are in grade 12, if possible, find the value of q. We're going to continue from here, from tomorrow, find the values of q. Any questions so far?
Why are you equating the profit to 0?
You can just kindly repeat your part.
At this point, you can leave it as it is, get the variables as they are. Okay, I just wanted to simplify them so that you have a 1 here. You can divide by 0.12, 0.12, 0.12, so that you have, you don't deal with decimals. But if you want, our A is 0.12, our B is negative 1.8, our C is 6 as it is. But there's no harm. They divided here throughout by 0.12 just to have constant figures.
Or as a quadratic equation?
Yes, as a quadratic equation, yes.
Okay.
So I'll leave you here. You do that as your homework. I'll require that tomorrow. So we start from here. Then I'll take you through the other questions. And this is basically what optimization is all about. Are we together?
No. Which one is our homework?
Your homework is this one here. Find the values of Q using the quadratic equation.
Okay.
Yeah. All right.